shall we get started? Awesome to see every one of you here. Hope to give you some insights into what we're doing. Let's also, I think, throughout the whole thing, if you have some questions or whatever, I think please raise your hand. We can make it a bit more interactive, but also at the end we'll make sure there's some room for it. So my name is Jelmer. I lead our analytics and ML at TEQnation. Started there around 9 years ago, just a little bit after TEQnation got launched. And before we sort of dive in, I want to give a bit of an introduction into what TEQnation is doing. So for maybe many of you may have used our services. We started a bit with this concept where many people are effectively spending a lot of time in supermarkets and driving there back and forth and not necessarily enjoying it, which is, I think, many of us don't necessarily enjoy our trips where we're basically carrying our stockables and our large grocery bags back and forth from the supermarket. It's not really an enjoyable experience. Separately, it's also actually not great for the environment as a whole, with actually a lot of waste happening, effectively due to poor forecasting in the setup that we have. Right, because traditionally we've had this sort of setup where supermarkets haven't really changed for the past 50 or longer years, where we have a couple of stores where we bring goods to from the farmers, and we have some warehouses in between, and it takes a lot of days to get your goods into the supermarket, and then we have customers driving back and forth to these stores to then collect these items that were actually coming from our suppliers. Which is actually quite a suboptimal process for many parts in this whole thing, right? Because these supermarkets don't really know how much these people want to buy, and these people need to go to these supermarkets to collect their goods, but even don't always know if they actually have everything on stock. Now, we then sort of started with, what if we take what we had in the past, which was this milkman concept, where we effectively have somebody that just drives around your neighborhood and has everything that you want, that has this personal touch to have this personal interaction with you, and combination of removing all of the negatives of you at the store. So farm to warehouses, and we basically bring this to your door utilizing modern technology. And I think at the time, usually ordering was still happening on your desktop computer, where we started with doing everything mobile, where we have only your Android and iOS apps, where you order your groceries swiftly and for us to deliver this the next day. And what the most interesting part of this is the moment you have this always with you, that actually changes the entire way of how people are doing shopping, right? Instead of having one moment in time for somebody to be at the supermarket to figure out all their groceries, now you have your supermarket with you effectively the entire week. And it has a huge benefit for people, but it has also a huge benefit for us. Knowing what you're already sort of shopping means we can already utilize that, and understanding of what you are planning to buy to have better way to improve how much we need to buy, which effectively has a big impact on reducing waste. Now, for many of the markets, as this was originally started, if you look at other segments like fashion, like electronics, etc., the moment this really sort of took off on the web was effectively we had a couple of key ingredients. Mostly that you are not paying more than if you would go to the store, especially in electronics you saw this, but also definitely in fashion. So that led to our lowest price. And secondly, to have the convenience. Many people don't want to wait your entire day for PostNL maybe to come around between 9 and 6. So being on time and giving sort of accurate timing when we'll be at your door, those combination effectively led to e-commerce taking off. Now, in order to do this, we need to have, we use a fair amount of technology to this. So to give you a bit of perspective, we are now operating at around 300 people in tech, where what you see as a customer is actually only maybe, let's say, 5 teams or so. We're of the total of around 35 teams, powering a lot of that, mostly all in-house, to where we have our own warehouses, our own warehouse management, our own drive optimization. And there's a guy sitting there that knows a lot more about that if you want to know more. And a lot of internal applications in order to make sure that we are able to deliver that efficiency and deliver that a great experience in the end for customers at high quality. So originally you started out in the Netherlands and then quickly expanded to Germany and now also into France. So you could wonder, I think the title of the talk is about ML, and so far we haven't even talked about ML at all. So where is it? And maybe you as a customer, if you have used us, you have also not even seen AI or ML sort of seeing even in our app. What I think, especially in the last 2 years, you've seen all the products out there, everyone is sort of showcasing what they can do with AI. And I think especially if you look many of the products that are coming out of Silicon Valley, if you are not boasting what you can do with AI, you're probably not relevant. And if you look at, I was going through a bit of the talks for what's happening today. I think sort of the word AI is everywhere. Reminds me of the Google's talk of I/O last year, AI. And actually also last week ago, I/O, you see basically if your product does not have the word AI in it, you're probably not doing the right thing. We have a bit of a different philosophy in a way of our focus is to solve customer problems and to solve business challenges, where sometimes ML is the solution and sometimes it's not. But maybe to give you a bit of a perspective of what we actually do with ML. So there's a lot of customer-facing what we're doing around personalization of what you see as a customer, around personalization of your shopping list, around promotions, and also topics like fraud detection. Similarly, on the supply chain side, given that we have a lot of vehicles on the road, to know how many seconds we are at the front of your door, if we can shave off a couple of those seconds, that has a massive impact into how efficient we can operate Picnic. Separately, forecasting demand on how many bananas we need on our shelves has a huge impact, one hand, of course, on waste, but also towards customer satisfaction. Making sure we have all the products rightly available is something you as a customer effectively demand, and is a perfect use case for AI and for machine learning. And similarly also for people planning. Now, if we go a bit back to a bit more of the beginning, I think, of Picnic, I think the main key question we've tried to sort of start answering is, what if, in a lot of these areas, what if you would apply machine learning to this? And would this be useful? Is this the right area where we should use it? And in a way, not only starting with the solution AI and see which problems we can sort of hit, but really do it the other way around. Now, at the time when we sort of got started, mobile first was sort of the whole thing where everyone was sort of shifting towards, we need to do something for mobile. We were already mobile, let's say mobile native, if you will. And the question sort of arose, what if we would be ML first or AI first? And that's what is quite surprising now in the last couple of years, with all companies and everyone talking about AI, and it's now finally here. But of course, if we go a little bit over the whole history, it has been here since many, many, many years, right? I think in the 50s and 60s, there was a lot of the research sort of starting And let's say your term of AI was quite, at the time it was more around philosophy, it was more about reasoning and logic. And I think a couple of key moments in history there. First of all, you had Deep Blue, the chess computer in the late 90s, where ML started to become a little bit more useful. I think it was still quite brute forcey, but I think more, let's say, thinking went into it and more useful applications started to emerge. Secondly, with AlexNet in 2012, so this was around the big competition that with ImageNet, and to sort of see where, for a long time, this whole concept of deep learning, where the concepts were already here, right? Deep learning is nothing new, but we needed compute, we needed power, and we needed sometimes a couple of smart ways on how to actually tackle this. Started to become actually relevant again. And this powers things like recommendations and more visual understanding, like working with images, working with video, started to again emerge. Interestingly, by the way, so AlexNet, one of the main people there was also Ilya, who went to be the leading scientist at OpenAI. Now, last week he left again due to many of their internal struggles. And then more recently, in 2020, you had sort of the launch of ChatGPT. I think the interesting part here is, by the way, this is already close to 4 years ago. That's already a long time. At the same time, a lot of the technologies and the things that they're doing are not necessarily new. If you think about transformers, they were already launched long earlier here. A lot of techniques that they're using were already known a long time ago, but effectively utilizing these technologies in this new way allows for new possibilities, and separately, of course, the fact that we now have more and more compute and data available, that helps us. Now, if you think a bit more about when and when not to use ML, I think the first thing that sort of starts is more of the understanding of when is it sort of useful. And so not necessarily knowing what all of your backgrounds are, but looking at, I think the big part of the crowd coming a lot from more traditional programming, if you will. I think in many cases, we're doing this, right? We get some input, we apply some rules, we have a bit of an output. In ML, this changes a bit, where we say we have input, we have data, and we let the system figure out a bit of the rules, and we get an output. And yes, that also means it's a bit more probabilistic. In deep learning, it gets a bit more complex. The rules become a bit more complex, a little bit harder to really figure out, and why sometimes a certain decision is being made. But conceptually, there's nothing more to this than this. And yes, I know I'm oversimplifying a lot here, so probably a fair amount of data scientists or ML engineers will not like this, but I think if we just look at it from a very much of an outside perspective, and when do we, comparing, let's say, building something in Java, Python, or sort of other traditional languages versus utilizing ML, this is sort of the main difference, right? Do we just hard code these rules, or do we give it a lot of examples, have it train something, and give us an output? And then the question is, how do we, and when does this make sense, and how do we utilize this? So as an example, would like to sort of go through a bit of the story for one of our topics, and I could have probably highlighted quite a few others as well. This is one where we have a very simple problem, and we want to know how many bananas do we need to order. So what do we do, let's say, at day one of picnic? Well, we look at a bit of how much data we have. Literally just a human looking at it, right? We just, like the first couple of weeks, maybe the first couple of months of picnic, just look at the data you have. Yeah, probably around this. Bit of a safety factor to it. Let's go. Okay, then volume increases a bit. This may be not really doable to do by hand, because also assortment is increasing, and we have not only a couple of hundred, but we have thousands of products that we need to do this. So we change this a bit into a rule. So we look at, well, tomorrow is Friday. The last couple of Fridays, we had about this type of demand, right? Every day is a bit different because people order different things in the weekend versus throughout the whole week. which is very interesting, by the way, as everyone's buying for the whole week. Why is then, are you buying different things if you're ordering in the weekend versus others? But of course, you can imagine maybe you have plans in the weekend, or you see things, for example, with kids especially, people are buying different things. Or if you look at what people are buying at night, a lot more cat and dog food, a lot more beer and wine, but also, even though we're not delivering straight away, right? We're even delivering maybe the day later, but people are still ordering more beers and wine. But also baby food, right? You're awake during the night with your kid, and you're starting to, you figure out that actually you're out of food, so you need to order more. So you start with these very simple sort of rules to sort of probably define a couple of bit of patterns. And then your rules become more complex, because actually then we figure out that it's also dependent on the weather, because if it's great weather right now, you're feeling like buying ice cream. But if it's raining now, you're actually maybe into comfort food or other things. Or maybe because it's nice weather, you're probably maybe going to be out this weekend, so maybe you're actually also changing your order moments. It's very heavily dependent on the category that you're buying, the type of weekdays. And the more and more of these factors you start adding, the more and more complex it becomes. And then your rules become more and more complex, and at some point, you're building such a sort of myriad of rules, this doesn't really scale. And this is where ML is great at, in figuring out these patterns. Of course, you need quite a bit of data. So day one of Picnic, this does not work because we don't have the data. We don't have this history. After 1 year, after 2 years, you can start doing this. Similarly, does it always goes perfect? No. After 2 years, we've maybe only sold twice at Christmas. So how do we behave at Christmas? The ML model will not tell us, right? It will give us an answer under regular demand, but Christmas is not a regular moment for us. Christmas is where people are buying tons of food, and they're also buying a lot of articles that are only even available during Christmas and not the rest of the year. So that means, first of all, that ML is also not your only solution, and you still need to combine this with, let's say, often combine this with humans to get great output. In order to do this, the main way how we try to think about it and how we try to approach the problem is not to spend months to years on trying to build sort of the best model out there, but rather start with, we have a problem, we have some ideas how we can potentially solve it. We build a very rudimentary, relatively simple model. We put it out there, right? We experiment a little bit, we do a little bit of back testing, we do a little bit at history, if possible. For forecasting, you have history, also with caveats, but you have history. If you look at recommendations, you don't have history, there's no way to sort of test. But you try to sort of get a good enough experimentation, good enough approximation of why this is probably the right way to do, the right model to sort of solve this problem. And you put it out there. And you see how things behave. And you compare it with a baseline. Now, the biggest realization is that this first model will probably be pretty terrible. And especially if you have already done this with manual or rules or other topics already maybe for 2 years, that means you're now suddenly in maybe, let's say, a month, you're trying to beat what others have been doing for the past 2 years. So, but recognizing the first one is going to be crap is already, I think, the first start. And then you start iterating. Maybe you try a different architecture. Maybe you try to add a couple of additional features. Maybe you try a sort of a different approach. Or maybe this works actually for a small subset of your articles. So very similarly, if we go a bit back to this example, the moment we started rolling out our ML model to do this forecasting, it was working beautifully for items that had a very high volume. Like for bananas, this worked perfectly. For toilet paper, works perfectly. For cucumbers, for milk, for all these that everyone wants. But we also have products that maybe are only sold a few times a week. Then it's super hard to find sort of the patterns. So it was not working so well for those. But still that allows you to sort of say, well, actually for those items, we're going to roll it out already. And for the other ones, we're still going to fall back on our old way of doing it. And over time, we're going to learn and we're going to iterate and we're going to try. And that's, I think, sort of the general sort of approach we're trying to take is often on day one, you're not going straight to the most complex model that you have. You often just start with a human doing something. For low volume, that works, and often they're actually pretty great at it. You start then having some rules. You add, you go to a more relatively simple model. And even if you know that that simple model, even if it's a simple regression classification, often you know this is not the perfect solution. But it already allows you to learn, to experiment, to get valuable data out of it. And it allows you to sort of already compare, will this already beat the rules that you have? And sometimes the answer is yes, and sometimes the answer is no. It also doesn't mean necessarily you always need the most complex model. In many cases, the simple model works good enough, and it's not even worth the effort to spend to go for the most complex version. But in other cases where you know that the impact is just going to be so big and there's a lot of tricky patterns, then it actually does perform quite well. So that's when we talk a bit about the models itself. But the models itself are only as good as the data we put in. And with all the chats and all the hypes and all the discussions we have around AI and LLMs, we talk about, often we don't even talk about our own models, right? We're just using something off the shelf we call an API. It's quite nice that we can just call an API and we get a response. But we don't really talk about this part, right? The mantra of terrible input, terrible output, right? It still applies. Shit in and shit out. So in order to actually really make a lot of strides and really have a way to quickly experiment and to have big impact around ML requires to have your data done appropriately. The way how we're thinking about it is to actually separate these two problems. Instead of having data scientists and ML engineers trying to gather data, clean their data, figure out a lot of this, and structure this and make it useful, you separate this. You let data scientists and ML engineers who are great at modeling, do that job. Whereas on the data side, you have data engineers who structure this, clean this, and build a central model out of this. And where at the time, I think in many companies, data lakes were sort of really the hype for people to go for, we went for very much of a central model. And yes, it takes a lot of effort to centralize everything and build one big central data model out of all the data that you have. But the moment you have it, that means actually that the job of a data scientist or ML engineer vastly simplifies to using this straight away, build a couple of features on top of it, and be able to launch that, instead of spending months into getting something useful out of the data. The average, I think, for most companies, around 8 to 12 months to launch a model. I really hope for all of you guys that's a lot less in your company, but in most companies it takes 8 months to a year to launch a model. That is extremely long. And it also, I think, means that many companies don't even want to invest that time. And now with LLMs, it feels like, well, we don't really need to spend the 12 months because I can just throw something in ChatGPT, get an output, and I'm good to go. First of all, they're terrible at forecasting, by the way, but they're still quite decent at a fair amount of other stuff. But having this stuff in order allows you to vastly reduce the time to market for your models. And then when you are actually developing, don't develop in isolation, right? Don't only basically have a couple of engineers somewhere in a room trying to figure out what is the best model, but collaborate with the others, because there's a lot of knowledge often in analysts and others who know the domain, who know sort of the challenges, and you effectively can quite easily encode that in the models that you have. Now, when we started quite a few years ago on where ML and AI was, I think, much more of a sort of an R&D type of function in Picnic, right? So initially, a lot of the rest of the company was doing either things manually or was having certain rules in place. and sometimes quite smart rules of doing it. But that meant that we were still sort of experimenting, we're still actually we're maybe not putting it completely core to all the products that we have, which is quite different from today. And I think the main key things to think about this are a couple of dimensions. I think on one hand is how quickly you can encapsulate your data. So this is historical features versus utilizing real-time data to make your predictions. It's a difference between manually retraining something on your laptop versus having something continuously training on like a weekly or maybe a few days iteration. Organizationally, the difference is in using models as an additional insight on how this could maybe, what maybe would be possible, versus actually making it operationally critical as part of your core proposition that you have. It's a difference between predicting maybe once a day, let's say a forecast or something else, versus actually rolling out and continuously testing and A/B testing in production with shadow deployments and comparing different models against each other. And lastly, once it's actually in production, you're not there, right? Even if it's performing well, you need to continuously monitor on how these models are actually performing, right? Your data is constantly changing. There is a lot of model draft that sort of appears. You're not done. And that's a big difference compared to, I think, a lot of the more traditional programming languages and solutions. Usually once it's there and it's working well, we can sort of move on to the next problem. So some of the insights we derived over time. I think, first of all, don't forget all the boring but extremely high impact use cases. It's super cool to play around with a lot of the new sort of tech that is sort of emerging. But where often for most companies where you still get to use the biggest impact is often in the more boring use cases, right? If we talk about forecasting, if we talk about classifications, if we talk about relatively, and it doesn't necessarily means simple, but it's maybe not the ones that are the biggest hyped, but still has a huge impact to you as a business. Separately is test in production. You can spend months to years offline in your corner to figure out what is the best model, but the only way how you can really learn is just to put it live and see how it actually behaves in action. And then from there, quickly iterate as possible. And it also means that you need to have a constant drive on how can you improve that iteration speed, right? What can you standardize? What can you take away in terms of complexity? How can you make deployments easier? How can you make your gathering your data easier? Only in order to increase your iteration speed.
I do have a question about the fourth bullet point, impact-driven model development. So,
I love how you make asking a question before we even were there.
Okay.
No, go for it.
Well, you mentioned, or you talk about forecasting a lot, right? But to have like a model, is your model like flexible enough to, to see the impact on making the most money, giving the customer the best experience, or reducing waste, or is the model flexible enough to kind of optimize on various areas of impact?
So that.
So what's the intention with the model? Do you want to, make the most profit? Do you want to help the customer the most? Do you want to minimize waste, or do you want it all? Is it flexible enough?
So that is, to answer that question is really, it's up to you, right? The model does what you set out to do, and I think the question that you're raising here is how do you make sure that you make the right trade-offs as you're building these models, as you're deploying this? How are they flexible enough to take these things into consideration? I think the crucial point is before you even building anything is to be very clear on what you're trying to solve at the first place. Are you only doing this to reduce waste? Are you only, then you probably get a great model. So if I want to improve waste, I'm not going to order anything. If I don't order anything, I can't throw anything away. However, the customers are still quite unhappy, right? So you need to define upfront what the weights are. Do we rather have a bit more availability so that you all can always order what you want and having a little bit more waste? Or do you really want to primarily reduce waste at the cost of the customer not being able to order? And to do this, what often helps is to, so waste is an easy one where we can just put a euro number value to how much we're throwing away. When something is not available to a customer, it feels a bit untangible. At the same time, if something is not available, we can look at our past data and understand, hey, does it mean you're not buying that item, right? Because we don't have it, so we lose a bit of money. Maybe you're not even ordering at all because this was maybe diapers for your kid, and if that's maybe a key ingredient for you to buy, because otherwise you go to a store next door because you really need your diapers, then it even means you're not even ordering with us at all, and maybe after you went to other supermarkets, you're also not even coming back to us. So we also have some money lost there. And the moment you start analyzing that and putting that number value to it, you're able to make that cost function, and then at the end it's a choice that you make as a company or as a lead where to focus on. In many cases, it's relatively a simple trade-off. In some other cases, it's a lot harder. If we talk about recommendations we do for our customers, on one hand, we want to provide the best recommendation for products or for recipes as possible, but at the same time, we also want you to explore a little bit other things, right? Similar to what the challenge things like Spotify have, right? They want you to also listen to other music. If you are eating potatoes, veggies, and meat every single day, like many people in the Netherlands, if we are recommending Thai, you're probably not going to buy. But if we're going to recommend every time some potato, veggies, and meat, but just a different variation, you'll probably keep buying them, but at the same time, we're not really helping you as a customer. So that also means that even though you're not even able to in data see why this is sort of the right choice, even you as a company might still say, I find this important, we're going to prioritize this anyway. So everything is possible, but you need to define that upfront. However, I think that to this point of 4 is really, if we also look at our data and the possibilities that we have, there's a gazillion models we could be making and many cool stuff we could be doing, but the key thing to make ML work for you as a company is really to look at areas where it hurts, right? And utilize it there where with patterns, etc., where it's good at, instead of where I think many companies have their challenge with is there's a lot of research and it's cool, but it's not actually useful. And we try to turn it around and look at where could it be useful and apply it there. So point 3 was around the teams and having people collaborate on these. Don't see this as a ML-only problem. It's a problem that you need to solve together. And lastly, on point 5, in order to really maximize impact, it requires also to transfer learnings from one to the other. Challenge we have around forecasting maybe or deliveries, where we are using transformers. Learnings from that apply very well to other areas where we're also utilizing transformers. They're not the same model, they're not the same area, they're solving maybe a completely different problem, but the underlying architecture has a lot of similarities, where therefore, in order to actually really make step changes, it's important to share these learnings. So we didn't even talk about this, about LLMs, and mostly because I think well, today there's many other talks that go into this, but I do want to touch upon sort of a couple of cases where we are utilizing it and where maybe these are not so obvious cases, but they're actually pretty great at. First of all, if ChatGPT can write things pretty good, why can we not have it write our product text for us? We have thousands of articles. We have around 30,000 articles that we sell. We have copywriters writing these things on a daily basis. But if I give it the product name and do a little bit of prompting, in about 30 minutes, I'm able to generate product copy for our entire assortment. Is it perfect? No. Do we provide a better experience for customers? Yes. Do we also make the lives of our copywriters better? Yes, because let's be honest, they also don't really enjoy doing this every day. But separately, it also gives us new possibilities, right? If maybe, for example, in our French market, we still have a pretty small team, they don't have time to write all of this, but now suddenly we do. That's a simple text example. Secondly, if you consider more topics like embedding, to generate complementary products or relevant recipes to what products you're sort of looking at, these things are great at. They understand the relationships between these things. They understand the relationship between your pasta and what great things to go with that. And it means we're not even looking at optimization for efficiency, but yes, it reduces quite some significant manual work, but it also allows for a lot of new possibilities where this is not rocket science. This is something you can do within a day. And that's where I find that whilst you can do a lot of complex stuff also with, let's say, LLMs, embeddings, many of the other things, and ML in general, there's also a lot of low-hanging fruit where you can already sort of utilize it. So also start small and use it already where it's possible. Separately, what I found quite amazing is that is for the cases of search. So where search traditionally has been keyword search, right? I search for wine, cucumber. If I'm baking an apple pie, think, okay, I need flour, I need eggs, I need butter, and I start searching for all these things separately. But why can I not search for apple pie? Why can I not search for wine that goes perfectly with my camembert that I already have in my cart? And this is also cases where LLMs can help, right? They understand these relationships. And whilst we're not boasting and not sort of showing to you as a customer, hey, this is something generated with AI, this is something we, on the back end, we are able to do, where we understand these relationships and using these small hints, right? This goes perfectly together with your brie. It's a very small copy, but it allows you to do these type of things and understand your users better, to actually understand the intent of what they are trying to do. It also allows you to explain it. Hey, we are seeing this because you love Mexican food. Or we are seeing this because your favorite snack is back in our assortment, etc. Lastly, I think many people also are still wary or are, let's say, criticizing a little bit of the quality of all these LLMs. And I agree. However, I think what the better way to think about this is mostly thinking about where will it go, right? What we start building today, we already assume that these models will get better. We assume they will improve over time and these will come. If we spend a couple of months trying to iterate, these other companies are able to get better models out there. And that is, I think, a vastly different way of thinking of what many are still doing on saying, it's not good enough, we don't want to show this to our customers. Do try it. Start small. Start with small users. Because you know these things will improve, and you will need to have time to iterate. in general, I think it's good to realize that ML is a journey, and ML is a journey in your company. And some companies have started later, where you maybe have already a huge focus on this. Some other companies are older, bigger, where maybe it's not applied everywhere. But I do feel it's important to realize that it's a journey over time, and step by step you are able to integrate this more natively into the products that you're offering. A great path, as far as how we have understood it, is starting with relatively simple heuristics, utilizing it for insights already as an additional way for people to collaborate with it, seeing the value of it, bringing it closer and closer to our products, and natively more integrating it to our products, and then over time actually allowing everyone in our company to utilize it. If you want to chat a lot more, we are also here at one of our booths downstairs. If you find ML in general exciting, we're looking for a lot of cool people, bright talent people, so feel free to join us. And curious if you have any questions. No, so we find it important that people take the whole end-to-end responsibility. So in some companies, you see data scientist builds model, some other team deploys. In our case, if you do something with machine learning, you do the whole thing, right? So you do the analysis, you figure out, you build your model, you iterate over your model, you do the deployment, you look at the results. So that means ML engineers are also using Kubernetes. They're also looking at, they're also just deploying these things themselves. They're also understand their infrastructure, setting up things with Terraform, et cetera, et cetera. So where do you draw the line? I think the line is, I think we have interpreted the role mostly as a software engineer that can also build machine learning models. So your question was, if we take a fail-fast approach, and how do we get feedback? And do you mean feedback from customers, or do you mean feedback from?
Well, more in general, obviously, when you put something out there, you want to know what the result of it will be, right? So,
absolutely.
So can you tell me a bit, tell us a bit more about the different approaches you take to that?
Yeah. No, so I think the fail-fast approach is not only for ML, I think for all of software, right? So you have a problem, you put something out there, often the first solution is not the perfect way, but you develop that over time. We have also there, I think also with topics like architecture, we have taken rather the approach to being a bit more pragmatic than to have architecture boards and spend a lot of time on what is maybe the perfect architecture for something, only for a couple of months later to get a different problem where we need to throw everything out of the window and start again. So being a bit more practical there and solving the problem that we have. Of course, you need to balance and still need to think about generalizations and how does this thing scale towards the future. So then, therefore, that also applies to ML in that regard. On your second point on getting feedback, there are, I think, separate, or there's a couple of different areas. First of all, very simple, if we're putting something out for customers, you want to get the customer feedback just to understand how people are using it. It's very qualitative feedback. We have our own beta tester group within Picnic, so we're putting everything out, first of all, ready for our own employees. where people can already utilize it, see how it works, and give feedback on what they see. And that qualitative feedback, whilst it's a lot of text, there's a lot of different opinions, it gives you a lot of valuable input on how people think about it and what they value. And still often cases where, hey, we actually did not think about it, or a cool example was when we were recommending recipes for people, there was this, one of our colleagues, I think she had only purchased a couple of dessert recipes with us. So we were recommending only desserts for her. Now, of course, it doesn't really help you if you're trying to also actually build your main meals throughout the week. So, hey, that gives us directly sort of the feedback loop. We also need to incorporate that. We just simply didn't think of it to make sure we actually have a diverse set of recipes that we recommend to our customers. Secondly, you have more your traditional observability. If you have your model out there, what's your response time? How often do you, is your retraining still happening, right? So making sure you get some observability around that. So your very traditional software observability you need to have in place. And then ML has on top of that additional observability where you need to understand your model drift. You need to understand, hey, if you're having various models that you're comparing, to understand, are they actually performing better? In order to do that, we always have a baseline in place. Even if the baseline is still a manual something, or it's a super rudimentary rule, you always want to compare it with the baseline. For example, in the forecasting case of bananas, hey, we still take the simple approach of tomorrow is Friday, let's see what the past Fridays did. We know that the prediction will not be great, but at least it allows us to compare that compared to what our model does. And often what you then see is that it works great for a super large set, but it also actually works pretty terrible for a couple of other examples. And it allows you to dive in those examples and utilize those to improve.
Yeah, I'm interested also a little bit in more complex algorithms and where you would put these in this new era of ML, because of course you have a routing problem that you're solving and do scheduling, maybe also frequent item set mining. Where do you see these algorithms, and are they here to stay, or maybe even combined with ML?
So your question is whether we think if the complex algorithms, like more sort of operational research type of problems, if they're here to stay or not. I do believe they're here to stay. Like if you take your classical traveling salesman problem, that still exists. We still need to make the optimization. We still need to figure out where we're going to deliver when. However, it's the combination of both where this becomes powerful. So for this particular example, we do routing for our customers, where we need to figure out which customers do we bundle together in the trucks that we have for our customers. And if we do that as efficient as possible, we have the least trips and we have the least cars that we need in order to do that. Now that is that's a problem that AI is not necessarily great at solving. So you still use your more traditional, even though there's a lot of still state-of-the-art models coming out there, on solving those problems. However, the inputs for it, how many seconds are we in front of your door, that is something where AI is great at. Where we can look at, well, we have never delivered at you, but we have delivered to your neighbor, where you can literally use nearest neighbor algorithm to figure out how many seconds will we probably be at your door. And that combination of both is where sort of it really shines.
Well, I was wondering, since you're implementing machine learning, have you noticed an actual improvement on your stock, that it's more accurate to the demand? So do you have numbers to track it, to see how efficient it is?
We do keep track, and that relates a bit, I think, to his question. It's super important to keep track of that, right? And to compare it with maybe your previous approach and to really understand how much value this is bringing. For us, our mission is not necessarily to have ML everywhere. Our mission is to solve problems, and these problems happen to be greatly solved by utilizing machine learning. So I don't have the numbers here, But I can definitely safely say for a lot of these problems, there's the impact of using ML is usually greater than using more traditional rule-based approaches. Doesn't fully answer your question, I think, but and maybe you can. I think we have a couple of blog posts on this as well, which you can read. But yeah, there's a huge gap between, let's say, more your simpler approaches and using ML for sure.
What do you see like challenges or opportunities like in the future? So we talk about forecasting, but you can also, you talk about personalized experience, right? So if you have some stock left, you can also promote or dynamic price products to
Absolutely.
sell them as well. So
Yeah.
how do you see or foresee that in the future?
So future-wise, so we are already doing more and more with personalization, and we'll continue to do more with personalization. A challenge we have and that will only increase is that you get a bit of an odd mix, because on one hand you make a prediction on how many stock we need to have, and then on the other hand you're trying to sell this stock as best as possible. But the recommendations what we show our customers influence how much stuff they will buy, which influences how much stock we need to order. So there's a very interesting feedback loop that is sort of happening there. One of the ways how we try to tackle that is to utilize the data we are, like what we're showing our customers as input to how we are predicting what we need to buy. This means actually using the analytics and events of what customers are seeing as features that goes back into our forecasting algorithms. And then also the other round, knowing the stock that we have, what do we show to our customers? How do we rank these products? Hey, if we have a big stock of this other item left, if we in search rank it a little bit higher, you're more prone to buy it. Of course, people still have choices, but if you are a bit indifferent first product versus A versus B, and we just happen to have way more of B and otherwise we would have waste, we can just rank or show that a bit differently.
You're already doing that? Or?
We are already doing that, yeah. And then, of course, on top of that, you can also play with things like promotions, etc. But often, if you just rank things differently or show things differently, that already has a big impact. Can you read, sorry? It's a combination of machine learning and
human input to make decisions.
Absolutely, yeah. And in some cases, we're able to have, we can fully trust the output, and so for example, how many bananas we need to buy, no human is looking at that when we just place orders with our suppliers, whereas in other cases, we have a combination of both. So in generation of product text, there's still human looking at it. If we're looking at, if we evaluate recommendations for recipes, do these make sense? We still evaluate and have humans involved. To figure out which issues customers are talking about or or who to route this to. We have humans still giving the feedback, hey, we classified this as a problem with your delivery, but it was actually a problem with something else. So humans are still essential to it, so it's really in the collaboration of both.
You're aiming to reduce human input, right?
Our aim is to reduce, I think, the repetitive work, right, where you can utilize this greatly for. Nevertheless, it doesn't necessarily, it's not about replacing, it's about utilizing what both are great at. I think we need to wrap up. Thank everyone, and have a wonderful day.